Myself, I am Dr. Jntuh. In this class, I am going to discuss with the file system implementation concept. As we know that file is a organized collection of data which will be arranged in a hierarchical memory. Here we are having several disk and memory structures used for implementing the particular files. Depending upon the operating system, the structure of a file may be varied. On the disk, the file system may contain the information, how to boot up and how to store in the operating system like that. A boot up control will usually contains the information that is needed by the particular operating system. The volume of the first block will be stored in a boot block. It is called as an EFS block. In the NTFS, the partitioning boot sector will also be there. Another block in the disk is a volume control block. It will contain some volume or the partitioning detail, such as the number of blocks in the partitioning, size of a block, and how a free block is going to be counted, and free block pointers, free block FCP count, and FCP pointers. So, like that, the UFS is going to be classified, and this block is considered as a super block. For the file system implementation, a directory structure is used to normally organize a file. In the UFS, it includes a file name associated with the inode numbers. It usually stored in a master file. The information per file control block will be stored in a FCP that will normally contains the information about the file. It has a unique identifier that will allow the different types of permission that can be stored in a master file table that stores the various relation database structure with a row per file that can be accessed with the help of a ACL, that is access control list. Here, a typical file control block has been listed here. A file will be having a file permission. File will able to create, access, and write a file. File will be having a group of file or owner of a file or access control list. What is the file size and the file data blocks pointed to the data blocks. Moving to the next one, that is a file system memory will be having the both the information that will be having an inbuilt of information. In this inbuilt of information, both the file system will be having the mount table. So the mount table is nothing but we are going to contain the information in that particular mount table in the form of a directory information that can be accessed by the another directory while it is necessary. The system-wide open file table which contains a copy of the FCV block. It will open a file as well as it will close a file whenever it is needed. We are going to process a table when an open file is going to be contained in that. A pointer here will operate at a entry and it can capable of opening the white table entry. The buffer will here act as a reading disk and it can also be capable of performing the writing content into the disk. So this can be explained with the help of this diagram. Here the diagram for a file open. Here the user is going to open a file name and the file name is going to be stored in a directory structure under a kernel memory. After the directory can be accessed to the directory structure and the file control block, which is in the secondary memory where we can read and write a file. Next structure is file read. Here the user space is going to read the index of a file. Here the index is stored in a per process open file table. After that, the system will be open for a wide open file table. It will be classified into the data block as well as the file control block. This is how a file can be read in the secondary storage devices. Moving to the next one, that is partitions and mounting. Partitions are nothing but a disk can be divided into different slide that is called as a partition. Here a volume can be spanned into a multiple partition that is called as a drive. Each partition here can be containing the number of file system either can be used in the Unix system or in the Windows system. Here the bootloader use the particular file structure will find and load the particular kernel and start execution after that. The bootloader that understands the multiple file system and the multiple operating system that can occupy the boot space as well as that is mounted in the particular table. The next concept is virtual file system, that is otherwise called as VFS, that is provided only in the Unix environment. Here, the VFS allows the system call interface API. The first layer of this file system can be open, read, write, and close calls are the descriptors. The second layer will contain the virtual file system. So it performs the two different types of function as it separates the file system from the generic operations by defining the different types of interface. By interface only we can able to connect with that particular system. Second classification is it provides a mechanism of representing a file throughout a network under a common structure that is called as a vnode. It is a unique file identification. Network-wide unique file identification is used. So this is a schematic view of the virtual file system. The file system interface will interpret with the VFS interface. Here, after that, the local file system has been derived. The local file system has been stored in the disk drivers, and the network can be accessed with the help of the network interface. So moving to the next one, directory implementation. So in the directory implementation, the selection of a directory and allocation of a memory is depends upon significantly. It depends upon the algorithm which we are going to use in that particular list. By this, the first classification is the linear list. So linear list is the simplest method of implementation of the directory. Here we use the linear list of file names. This method can be simple to the program. We can create a program here. First search the directory rather than using the existing file. We can create a new table entry here. At the end of the file, if we want the file, we can make it, or else we can delete that particular file. We can also capable of reuse the directory entry by assigning a special name attached to the particular directory. So the disadvantage of the linear list directory is finding a file requires a linear search. So the time consumed here is very, very large. For example, the pointer data blocks are here in the file name. If I want to search a file, for example, a cybersecurity class, it is listed in the 10th file. So I have to search linearly. From the first file, I have to search second, third, fourth, file, moving up to the 10th. So this will increase the time length. So the major disadvantage of this particular file is the time consumption is very, very large. Moving to the second one, hash table. In the linear list, we have to check for the each directory list. Here we'll store the directory entries by using the hash data structure. Here the file name returns to a pointer that having the linear list. So it is comparatively straightforward. We can directly access to the particular file. For example, so this is hash table entry. Here the hash table entry key 2 is going to be searched. It has a value of 2, hence it directly listed to the particular file name, that is 2. So directly listing the key value to the particular file name. Hence we can easily locate the file. So the main disadvantage of this implementation of a hash table is the collision can be occurred because the key value or the value may be sometimes overlapped with the functions. Moving to the next one, that is allocation method. Here in the file storage, we are having the different types of allocation method that are used in the disk space. It is divided into 3 categories: contiguous location allocation and linked allocation, indexed allocation. The main idea of providing this is the efficient disk space utilization and the fast access and the retrieval from the file block. Moving to the first one, contiguous allocation. It requires each file will be having the particular contiguous block of disk. Here the file can be stored on the disk in the contiguous memory location. Whenever we are making the particular file to access from the system, we can make entry of the particular file name into the directory and we can access it. The main advantage of this contiguous allocation is we can start only with the address. After that, we have to specify how many number of length of allocation we are going to proceed it. So this is an example for the contiguous allocation of disk. Here a file mail has been created with the length of 6 and 19 blocks here. It occupies a different number of counts. We can use and start the length as 19. So 19 to 24, it represents the mail condition here. For example, here different types of files are there. We are going to list a file mail. So it will start from 19 to 24. It contains the length of file length as 6. 1, 2, 3, 4, 5, and 6. Like that, it is listed here. So this advantage of this contiguous allocation, it provides excellent and performance of our network is very, very fast actually. Here the file access method which we are using is a sequential access and both the direct access is used. Disadvantage of this method is external fragmentation and increasing the file size may affect the performance of a particular location. We cannot able to find the new file space of accommodating here. Thank you.